All right, the first part of chapter 9 is about what are called conics. And conics, there's a couple of different shapes that fall under the family of a conic. And we've talked about some of them before. So a conic is formed when you have a plane that intersects uh, a double-naped cone. So basically two cones on top of each other, but the points are touching. And depending on how that plane is intersecting one or both of the cones, you get some different shapes. If the plane is parallel to the bases of the cone, because here's your base of the cone and here's another base of the cone, if that yellow plane is parallel to that, we get a circle. And we've done circles before, so that's the first shape that we're going to talk about. Then the second shape we're going to talk about is a parabola. And we've talked about parabolas before. So if our plane is sloped in a way where it only touches one of the cones, but it keeps going past it, goes to the top of the cone or the base of one of the cones, then that is a parabola. Okay? And that's going to be the second shape we study. Then the third shape is going to be called an ellipse. So in this case, the plane is touching one of the cones in two separate spots. That gives us an ellipse, and we may know this as a more general term, an oval. Okay, so a circle is a little squished a little bit, that would be an ellipse. Now, if our plane is perfectly vertical, it will touch both cones, and that's called a hyperbola. And we've actually seen hyperbolas before, not in this exact form, but when we graphed rational functions and we had those two branches that go near the asymptotes, those branches were called hyperbolas. And now we're going to do that more in depth, and that's going to be our fourth one. Now, if our plane intersects at just one point or intersects at just one line, those are called degenerate conics. We are not learning about those this year, so we don't have to really worry about that, but just wanted to show you what that would be with different cross sections, because we talked about all the other cross sections of a plane, but what if it only touches at a point, or if it's just touching that plane or that cone at a line? We're not going to learn about those. Now, the general form of all of the conics we study is in this form: ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, where all those letters are integers. But again, what we're going to be working on are only when we don't have a b value. So we're not going to have a term that is multiplied by x and y. We're just going to have an ax squared, a cy squared, a dx, and ey, and f are a constant. It will equal 0. So again, the forms that we're going to be looking at are ax squared plus cy squared plus dx plus ey plus f equals 0. We're going to have two types of problems in this chapter. We're going to be given the equation of a conic, and we're going to find information about it and graph it, or give information about that conic and then find its equation. We're going to be using completing the square a lot in this chapter because we want to put it in, factored forward or with parentheses in it, and we know that we can do completing the square by grouping the x terms, grouping the y terms, and doing that b over 2 squared idea to get the to complete the square and get that binomial. So the first one we're going to talk about is a circle, because we talked about circles in geometry class. We talked about circles in Algebra 2. So this will be a good review of that and then bringing it forward to other conics. So the standard form of the equation of a circle is x minus h squared plus y minus k squared equals r squared. Now, we talked about h and k when we talked about the families of functions back in the beginning of the year. You know, the absolute, the quadratic, the cubic, the square root, the cube root, and we had those h and k terms. And the h value affected the x left and right, and the k value affected the vertical movement up and down. Same idea here, where our center is going to be at h comma k, the opposite of what we see in our parenthesis, and the r value is the radius. So a lot of people will forget to take the square root of that value to get the radius. And then x and y, this is a little bit new for this year, x comma y is a point on the circle. So sometimes I'll give you a point and then you're in a radius and you can find the center. As long as you have some of this information, you can find the other parts of the circle or the other components. Sometimes this is called the solution. All right, so let's go on the next page. It says find the standard form of the equation of the circle, of the specified circle. So center at 0, -2, and radius 3. So I'm going to write this up here so we don't got to keep going back and forth. Our center, h, k, and this is our r value. So it's going to be x minus 0 squared plus y minus -2 squared equals r squared, or 3 squared. Now, I know that at some point you won't need to write that, and that point may be now. Like, you may be able to look at this and go right to, oh, x minus 0 is x, so x squared plus y plus 2 squared equals 9. If you can go from this to that, that's no problem at all. You can do that. I know you've been doing equations of a circle for a while. So that would be the general or standard form of the equation of the circle with that center and that radius. Letter B. Center is at -3, 4, and the solution point is 4, 6. So this would be your h and k, and this would be your x and y. So we can substitute that in to that equation up there. So it's going to be 4 minus -3 squared plus 6 minus 4 squared equals r squared. 4 minus -3 is 7. So we have 7 squared plus 6 minus 4 is 2 squared equals r squared. 7 squared is 49 plus 4 is equal to r squared. So 53 is equal to r squared. Now, we don't need to figure out the radius. The question is not telling us that we need to figure out the radius. It's telling us what is the standard form of the equation. We only need r squared, which is what we have right here. So we can go ahead and write our circle down. So x minus -3, so plus 3 squared, plus y minus 4 squared equals 53. So that standard form has the coordinates of the center of the circle, but it does not have a value for x and y. But we used a value for x and y to get the radius. All right, now letter C says endpoints of diameter at -4, -1, and 3, -2. So if we have the endpoints of the diameter, in order to find the center, we can use the midpoint formula. So midpoint of diameter equals the center. So for the midpoint formula, we're going to do -1 plus 3 over 2, comma, -4 plus -2 over 2, which is going to be -1 plus 3 is 2, 2 over 2 is 1, and then -4 plus -2 is -6, -6 over 2 is -3. So that's our center, making this H and this K. All right, we still don't know anything about the radius. Now, you could do the distance formula for the endpoints of the diameter. That will give you the length of the diameter and then divide it by 2 to get the length of the radius. Or we can use one of these X and Y points here of the diameter as a point on the circle and do what we did over here in letter B. I don't like dealing with negative numbers as much as possible, so I'm going to use this point. So instead of X, it's going to be 3 minus H, so 1 squared, plus Y, -2 minus -3 squared equals R squared. So 3 minus 1 is 2, 2 squared is 4, plus -2 minus -3, that's going to be -2 plus 3, which is 1. 1 squared is 1. Whoops. Which equals R squared. So 5 is equal to R squared. Again, we don't need to figure out the radius. We just need the radius squared. So now my general form or standard form of the circle is X minus 1 squared plus Y minus -3, so plus 3 squared equals 5. So writing the equations given information is not too bad when it comes to circles because there's only a couple pieces of information I could give you. I could give you the center and the radius. That's really easy then. I could give you a center and a point on the circle. I could give you endpoints of the diameter. I could give you the length of the diameter, and you just have to divide it by 2 to get the radius. So it's just something that you need to think about a little bit. So most students do just well with writing these equations because you've been doing it in geometry and in algebra 2. Example number 2, find the center and radius and sketch the circle. Well, let's see. The center is going to be at -7, comma, +1. So 1, 2, 3, 4, 5, 6, 7, comma, 1. So right there. Our radius is going to be the square root of 4 because this is R squared. So radius is 2. So the way I graph it is from here, I go up 2, make a dot. From the center, I go left 2, make a dot. From here, I go down 2, make a dot. Right 2, make a dot. And that gives me the circle. All right, now over here, our center is going to be at 5, 0, because there's nothing with the y. So that vertical, that k value is 0. So we go 1, 2, 3, 4, 5, make a dot. Now the radius is the square root of 12, which is not a nice number, but if you round it, it's about 3.5. That will make it a little bit easier to plot. So from the center, I'm going to go up 3.5. 1, 2, 3.5. 1, 2, 3.5. So from the center, I'm going 3.5 or 3.5 in each direction, and then connecting them with a curve Don't draw a diamond or anything like that. All right, now the last example, find the center and radius of the circle when the equation is given in general form. So in this general form, we don't have h and k and r squared easily visible. So what we have to do is we must complete the square twice. So must complete the square twice. Okay. So we do it for the x's and we do it for the y. And I know you did this in Algebra 2 with trig last year. So I'm going to add 3 to both sides and rearrange things to get the x's together and the y's together. So x squared minus 4x plus y squared plus 8x equals 3. So I rearranged the left side to get the x's and y's together, and then I added 3 to get the constant by itself. So now I'm going to complete the square with both terms. So completing the square with x, so we get x squared minus 4x. So we complete the square with x. And remember, to complete the square, you take this b value and divide it by 2 and then square it. So this will be negative 2 squared, which is 4. So then I'm going to do x squared minus 4x plus 4, because this is what gets added. And then I'm going to do the same thing with y. So 8 divided by 2 squared, which is 4 squared, which is 16. So plus y squared plus 8x plus 16. Now, because I added 4 and 16 to the left side, over on the right side, I must do 3 plus 4 plus 16. Because that way, what I added on the left and the right side is the same thing. So now I have to factor each one of these. One of the tricks that you can do is whatever we square. So up here, we squared negative 2. Because we squared negative 2, it's going to be x minus 2 squared. Plus, and then here, we took positive 4 and squared it, so it's going to be y plus 4 squared. Equals 3 plus 4 plus 16 is 23. So now this looks like the problems up here where we could identify the center and the radius from that equation. So our center, again, is going to be the opposite of what you see, so positive 2 comma negative 4. And the radius is the square root of this number, so square root of 23. And you can't simplify that, so that's as far as it goes. So now with letter B. On letter B, you'll notice that there's a 4 in front of the x squared and the y squared. So we're going to do the exact same thing. We're going to put the x's and y's together and the constant on the other side. So 4x squared plus 40x plus 4y squared minus 10y equals 10. Now, when we have the first number not being 1, we can do two things. We can divide everything by 4. But again, that would only work for this specific circle because we have 4 and 4 there. So I don't want us to get into that habit. So what we'll do is we'll factor out a 4 from each thing. So each variable. So from here, I'm going to factor out a 4. So you have x squared plus 10x. And we're going to complete the square at some point. Okay. And then here, factor out a 4. But this is where it gets a little bit confusing. 10 divided by 4 is not a whole number. 10 divided by 4, and I don't want to use decimals because when I square a decimal, it becomes more confusing. So I'm just going to divide negative 10 by 4, which reduces to 5 over 2. And that equals 10. Now, and we experienced this at the beginning of the year working with quadratics, that when you complete the square now for the x and y, we have to multiply by that not GCF, by that number we factored out in front. So we factored out a 4 from the x's. So when we complete the square with x, we have to multiply by 4 when we add it to the other side. So we're going to take that b value, 10 divided by 2 squared, which is 5 squared, which is 25. So we're going to add 25 to both sides multiplied by 4. Sorry, take 25 and multiply it by 4 and add that to both sides. So 4, and then we have x plus 5 squared. So now we complete the square with y, okay, with this. And yeah, that fraction does make it a little bit more difficult. So we're going to take negative 5 over 2 and divide that by 2, which is the same as multiplying by 1/2. So it's going to be negative 5 over 4 squared, which is negative, sorry, not negative because we're squaring a negative. It becomes positive 25 over 16. So that's what we're going to be adding to both sides, but we need to multiply that by 4. All right, so then plus 4 times y minus 5 over 4 squared. So that finishes the left side completing the square for both variables. Now this is equal to the 10 that was there, plus in purple for the x's, we added 25 to both sides, but we have to multiply it by 4 because that's what we factored out at the very beginning. Then in the blue for the y, we added 25 over 16 to both sides, but we have to multiply that by 4 because we factored out a 4. Okay, so now the left side just stays like this. Let's make this a little bit neater. It equals 10 plus 25 times 4 is 100, plus 25 over 16 times 4 is going to be 25 over 4. So now we have to get common denominators so we can add up this left side. That's right, this right side. So still have this on the left side equals 40 over 4 plus 400 over 4 plus 25 over 4. So then we get 40 plus 400 plus 25 is 465 over 4. Well, let's go back up here. Our formula has no number in front of the parentheses. We have a 4 here. So we have to divide both sides by 4. Well, because we're going to be dividing both sides by 4, it's the same thing as multiplying by 1/4. This will give us x plus 5 squared plus y minus 5/4 squared equals 465 over 16. All right, so now we have the formula, the standard form of this circle. Our center is going to be negative 5 comma positive 5 over 4. just like it was for everything else, the opposite of what you see. The radius now is going to be the square root of this. Well, the numerator is just going to be the square root of 465 over the square root of 16 is 4. So that is as simplified as we can get this radius. So you really have to make sure your algebra skills are sharp. Right? Because I know you did stuff like this last year, but you didn't do stuff like that with dealing with these fractions. So just remember to take your time. It's okay to take up a lot of space if you need it. Don't try to skip steps if it's going to confuse you. So thanks for watching the video. Make sure to like it and subscribe.